Selmer Corvette. This amp's from about 1963-64. Thought we'd have a look at this. It's I think it needs a recap because it's got a bit of a hum in the background apparently. You can see it's in remarkably good nick for its age, just the speaker cloth's getting a bit flimsy. It's just decaying with age. I'll spin it round to the back. Not much to see on the back there. So let's look at the controls. We'll just pull it down. I think that's the easiest thing, so we can look at the top. So you can see there we've got volume, tone, amplitude and speed. Those are for the tremolo. I think what we'll do is we'll plug it in. So cables in the back here. So there's a new plug put on it. Let's check it. Yep, cracked fuse on there. Grip cord's loose. So we'll tighten that up. There we go, that'll do nicely. Right, let's plug in. I'm going to put the current limiter on. We'll start with a 60 watt bulb on the current limiter. Plug in. Let's switch on. There, on the tone control. Bulb's lit but gone dim. Giving us about 200 volts. But more importantly, it's giving us some protection. These caps are a bit dodgy. Oh yes, they are. My word. Tremolo seems to be working, but yes, that's got quite a hum going on there. Quite a hum. It's just looking inside it. My gum. Certainly didn't bother about safety in those days, did they? Look at this fuse here. This thing's live, so I've got to be a bit careful. Let's find something more suitable for pointing with, given this. So we've got this fuse here, you can see, just on here, and that's got the 240 volts going through it. And you can see these are all the tappings off the transformer. And certainly, if we look at the back, you can see here it certainly wouldn't take much, would it, to poke something through there. So, you know, using this amplifier to make sure that there's no kids around, by gum, it would be catastrophic. Poke something metal through there. Got the full HT. So we look inside there, we've got EL84, EZ80 and two ECC 83s, 12x7s, a couple of resistors in parallel there, and I'm guessing they are the cathode resistors, 820 ohms. Sorry, they're in series, not in parallel, excuse me. They're in series. Got a big resistor here, drop-in resistor. And a very wobbly capacitor. And that one's not much better, and a very wobbly board as well. But again, it's just the way it's made. Budget these amps were. Actually had a bit of a read up. They were budget amplifiers. Budget is definitely the word. Wow. So we've got this capacitor here. I wonder if we should be able to find a schematic for this amp. So this is just a little single-ended amp. Can we see any values on that capacitor? 32 microfarad on that one. I don't know whether it's a 2-in-1. 32 microfarad on that beast. And the other one is 16 plus 16. We've got 168 volts going in on the main supply, because of course I've got it on that 60-watt bulb. Can't really get in really, we need to take it out of the case. Just having a quick look round just to see if there was anything obvious. It's had some work done to it. There's a capacitor there being replaced. But not a lot of work. Right, I've got this out of the case, just plugged it back in, done a bit of testing. Just waiting for it to warm up. Has that come on? That is, we'll have to look at that. So I've squeezed the meter in there. So purple is the ground on there. You can see we've got 2.1 volts of AC there, and nothing on that one. So it looks like one side, just one side of that is a bit leaky. Yes, that's made it considerably quieter. So let's see if we can get onto this one. Actually, we can go that way, can't we? Because that's ground as well. Yeah, so it's that first, just discharge that. So it's that side there that we're looking at here, but the whole can will have to come out. What is the working volts of that, I wonder? So that's the symptom of that, of the noise. See what other problems there is. Somewhere there's a dry joint because this went off. output transformers on the actual speaker there. Right, let's have a look at this then. 144, 150, got more volts on the screen than the plate, not massive amount. We got there 5, 6, just 5 volts more. But no leakage on there, at least. So that's one of the first things we checked, just to see if there's any DC leaking onto the grid of that output tube, because they're very expensive these days, tubes and output, especially the preamp tubes are. So we don't want to be seeing any of that. So we've got this 16 plus 16 that we looked at, and that is going into this area here. One of these has got to be ground, and obviously I'm guessing it's got to be that one. Let's just pop this back on ohms. Yes, that's a no-brainer, isn't it? Right. Let's just plug back in again. I should unplug it when I turn it over, because I don't want to short anything. And there's not much to hold on to chassis-wise, so I don't want to nip either off it, despite the fact there's not a lot of voltage going through it. Big difference of voltage on that, on each side of that. We got on that side 109. That's just ground again. That one, what we got on there? Oh, 117 and 108 on there. So they don't seem to be humming. Just seems to be that first node. Nothing. So needs a new capacitor on this first node. It'll have to be on the second node probably as well. Because we'll have to remove that whole can. I don't think we're going to find a can that will go in there. Might do. Might have to order that. May swap that one as well while we're in here. Make it more reliable while we've got the board out. Need to clean some of this flux off. Sort out one or two of these dodgy connections. And we need to just check those coupling capacitors on those grids, on those preamp tubes. And we obviously need to check the bias, which we can't do while it's on the current limiter. And I'm not taking it off the current limiter with that cap being how it is, because I don't want to pop that EZ81 or the power transformer. So there we go. That's a bit of just a quick look at that, an analysis of what needs doing. We need to go and look for some parts now, don't we? See what we've got. Let's check a few resistors, shall we? Start with these plate resistors. 105, that's acceptable. 108. Wow, he's well over. 4.7. Going on there. 6.4. So I'm afraid his days are over. So he needs to be replaced. I'm afraid that's quite high. Right, let's test these tubes. So I've got a EL84 Brimer and 5E1 168 Testis 3. Remember that off by heart. Done so many of these now. There we go. That, so you can see nothing wrong with him. Any shorts? No. He's a result. Just going to leave him out for the time being though. Let's try the EZ80. I shall need the book for this one because I cannot remember the settings for the EZ80. So we look in the book, as they say up north. So there we go. EZ80. There we go. 5E1, which is for the filament. 5E1. Testis 7. I think 5 is for the filaments. I can't remember now. Testis 7, and we should have two sides of that, 1 and 7. So get all these back here. Put the tube in. Um, 5E1, Testis 1, and we're on this bottom here diode setting. He's good. Yep, he's fine. He's a lumberjack and he's okay. Now we test these 12AX7s, which is 9E1, 3 and 8. 3 on one side. Let's test him. Yep. 8. He's a result. He's a Brimer. Let's have a look at the other one. He's a Mullard. A Mellard. So we'll pop him in there and we'll test his loins. He's a result. Yep, so the tubes are all good in it. That's good news, all good stuff. So all the tubes are good. We just need some capacitors. Right, so I've got the schematic here and it's not particularly easy to see on the camera. Don't know how well you'll be able to see this. It's just very faded. It's the only one I can find. So let's just have a look. 250 volts should be that drop-in resistor there between nodes 1 and nodes 2, and if you remember we've got the 1.45, so he's been swapped at some time. Cathode resistor is 150 ohms, and if we've got those two sand resistors in series in there, which are 820, you give us about 166 I've got written down there, 166 ohms. I think we'll have a look at that. We may remove that. 25 microfarad bypass cap, that's the one that's looking a bit corroded there. The 4.7 there, which is 6, which is about 6.6. that looks like it's on the first stage, so we definitely need to change that, because we'll be losing some gain off there. That's just about into cold clipper territory, so we need to change that. In fact, we could make that 3.3, just give it a bit more. It's gumph, madam. It's quite low, that. Sorry, quite high, that, sorry. 25 microfarad bypassing that. 25 microfarad bypassing there, so we'll have those changed as well, because I've had a close look at those and they don't look in very good condition. I think I've got a nice 250 ohm ohmite resistor that will go in place of that. Could put that back to its correct value. What have I got there? Yes, indeed. Not that it needs that, of course. 10 watts, which is what that one is, but we've got him there, and it's more a case of him. Let's just measure him up. Yes, he'll do nicely. It's because obviously we've got such a distance there, which is probably why they've used that. I mean, you could have got away with 5 watts there comfortably. So we'll put him in there. We'll find some bypass caps, change him, change Mr. Dublier there, and the other cap that came out, which is this one now, you can see. And we just need to test some of these capacitors. So we're looking at this 10 microfarad here. Now I think that 10 microfarad is this capacitor here, which says 4 microfarad. So I'm thinking that that is that capacitor. And the first thing is, if we look, it goes to ground at one end. So let's just test that first of all. So let's try this end. And yes, it does. So that goes to ground. And then if we look at the other end, the positive, it connects to a 270k resistor, a 27k and a 97 plate resistor. Well, I'm guessing that will now be 100k. Am I right there? $27k. Sorry, 270k connects to the 270. That goes to pin 1 from that 270k. So connects to the 270. 270 connects to 100k, goes down to this, to pin 1. So let's see if that's correct. So these that I thought were 290k, they're actually 270s, and the purple's just come off them over the years, baked off or whatever. So let's just try that. Yep, so that's the connection there. If we look at that, that's our connection there. You can see it. Well, you can see that. And there should be a 100k resistor connected to that. Well, I can see a 100k resistor there. Yeah. And if we go to pin 1 on the tube, there we should see 105. Just about see that on the meter. If we go to pin 1, we should see 105k, and if we connect there, yeah. So that is 4 microfarad in this amp, and that is 10 microfarad on this schematic. So we'll change that, and we'll upgrade it, see if we can find a 10 microfarad. Now it says 10 microfarad at 300 volts. No voltages on there, but I would have thought that's way over, because we've no voltage on here as I can see, but what we've got 180 with the 60 watt bulb, so I can't see us having 300 volts that far down the line. So we'll probably get away with a 250 in there, but we'll check that. But we definitely need to replace that. Right, I've just got that humongous, well it is for this amplifier anyway, removed that. That's what they'd used to bridge this trace with, and obviously to get this, the heat into this, it being so thick, and by the time they have the trace has gone there, it's just, this is a mess. So we need to address that. Didn't need anything that thick, did they, to go across there? All they needed really was a resistor lead and just a quick touch of the soldering iron either end, and it would have been fine. But, and obviously I've had to melt that, and by the time it's the solder's melted, the tracer's burnt up because the excess heat in that. Not required. But there we go, that's ruined that. So we might as well just say goodnight to that trace completely. Now I've snipped out those cathode resistors because they were floating around a little bit, and there they are. And we're going to put something in a bit more substantial. You can see, as I say, we've got the ohmite resistor in there, and he's nice and solid. Clip this bypass cap out now as well. And we can see, if we look at the end of him, he's a little bit, we just go in a little bit, you can see he looks a little bit corroded, doesn't he? There on the end. So again, it wouldn't surprise me if it tests okay, but they're just looking a bit mouldy o dough. And while I've got this amp in and working on it, I might as well replace anything that looks dodgy. And that again tests okay, 22 nanofarad, but it's just all corroded on the end there. Looking back here again, I'm getting a bit tangled up with the wires. This amp doesn't have an HT fuse, and as anybody's watched my channel knows, I generally don't let anything go off my bench without one, because really all amps should have HT fuses. Just makes sense to me. So while we've got these gaps, these now tracers broken and so forth, I'm going to solder an inline HT fuse into this amp just for safety, just to protect it. And remember, this is a really old amp, so you know we don't want to see this transformer burnt out. So an HT fuse will be a wonderful idea, I think. So I'm going to put one of those in there, and it should be most splendid. Right, I've done a bit of work on this amp, and I've removed this capacitor here, which is all sledged up and Genji, which is 10 nanofarad, 0.01 microfarad. Because he looked a bit messy, so I've taken him out. Now that capacitor is that gentleman there that's unmarked, so we can now mark him down as 10 nanofarad. I know what that is. So yes, he's very grubby. We've changed, I've decided to just change the plate resistors because I don't want this amp coming back frying in a few months, so it is only 4. So 100k has been changed there. There's our new 22 microfarad. Put a 2.2 in there on that first stage instead of 4.7. That 4.7 was, seems a bit of a high value for a first stage. Also, it was over 6k, so it would have, that really would have been stifling some of the gain. So we've changed him. I think the other 4.7 is on the tremolo circuit, I think. I'm not sure about that. Just having a look now. Well, may not, maybe not. So that must be on that latest, is a later stage here. So that 10 nanofarad goes along there and then comes back up into this grid here, and then that cathode resistor's there, and then the tremolo is on V2A and V2B, V1B that is. So that is it on that gain stage. So we may just change that one as well, just lower that one slightly as well. Now that's interesting. That's got a 47k picofarad. Is that 4.7 nanofarad? It is, I think. Right, we've finished getting all the components in. We've cleaned this board up. We've repaired some tracers that were badly damaged, and we've had to improvise a little bit with these capacitors. I've cleaned all the flux off it as well, so it looks much better now than it did before. Do we look, we've got a couple of 22 with 500 volts working, but it doesn't really matter. They're Nichicons in there, so we've upgraded those from 16 to 22. They've gone in and we've managed to get them side by side. We've got some glue around them. We've changed all the plate resistors. There's only 4 of them. We've changed just because more reliable. We've changed this 22 microfarad capacitor here on this first stage on the cathode. 2.2k now instead of 4.7. 100k plate resistor, 3.3k instead of 4.7 on that second stage, and 10 nanofarad replaced because that was all gooey and gunked, looked a mess. We've changed that. 47k plate resistor we've changed, another 22 microfarad there, another plate resistor there, and we've changed the bypass capacitor there, which is 22. And of it now, these capacitors here are the big ones that we've done. We've also put a fuse holder on there. We'll have a look at that as well in a minute. So we've got a HT fuse now. So if we look on here, we just drilled a small hole through there and brought that across. All this trace was gone anyway. It was all terrible. It was in a right state. So that had just corroded away. And then the heat, with me getting it off, just finished it completely. So we've remade a trace there. We got rid of that piece of thick gauge wire that was on there. That destroyed one of the traces. We got rid of that. We've got the fuse in there, and I've cut the trace off there to get the fuse in, because that trace, and I've just soldered that onto the wrong pin. Fool. Just realised, just spotted that. Was going to have a check round, but I've just spotted that on camera. That should be there, not there. Duh, my bad. Slap on the wrist. So I'll change that over. I've repaired a couple of wires on here that were in a bit of a state. And I've just got to check the other transformer. I've got these 2 clips on with a 150 ohm resistor tacked in, ready for a fire up. So we're ready to give this a fire up now. Well, we are when I've changed that wire over, because that wouldn't be very nice if we fired that up in that wired up on there. So we're going to fire this up and see if it runs okay. We're going to bring it up slowly on the current limiter with the bulbs. There it is on. Let's plug the amplifier in. So we've got 73 volts going into it. So we may need another bulb. So I'm going to put a 25 in with it. Let's see what we've got now. Got no voltage coming at all, have we? Which one again? So the pilot light's lit. Got no current to speak of. The bulb's dim. No massive shorts anywhere. Just don't seem to be getting any voltage coming through. And I've just realised why. Has anybody else spotted why? Because I haven't put the fuse in. Forgot to put the fuse in. Duh. What a plank. Right, we'll try again with the fuse in. Oh, getting some voltage now already on that bulb, so that's because the filaments have got really warmed up on that tube before the HT voltage. Even though there was no HT voltage coming out of it, the filaments got quite warm on that. So that's, voltage is showing quick. You normally have to wait a while. So pretty good going up. 7 volts. We've got 77 volts on the mains going into it. It's drawing 40 milliamps, so that's nothing. Just let that go up slow because we want to bring these caps up slowly rather than shock them to life. 40 volts, 50 volts, 60 volts and climbing. So that's just settled now at 65 volts. So everything looks good. So I'm going to drop the 25 watt bulb in with the 15. There we go, and now you should see that fly up. So we've got 40 watts there, and the amp's coming up, I can hear it. Silent in the background now, and the tremolo's just kicked in. The amp's flat out at that. The chances are, it wouldn't surprise me if this giving us a bit of interference as well. The old tone, switch on the tone control. So that's looking good. So we've got 124 volts. So have we got the other side of that resistor? 129 volts. So there's still about a 5 volt difference there. Might look to see if we can solder a screen resistor in on that EL84. Just need to clean those pots, don't we? You just need a little bit of cleaning. So we're drawing 80 milliamps on the current limiter. So those caps are 500 volt rating, so they'll take some gumption. More than this amp will give them. That's a 60 watt bulb now, and that's 100 62 volts we've got on there and climbing now, you can see. That's good. Stick with 50 in it. Get a little more. Now I haven't soldered that, as I say, I've tacked in that 150 ohms with these jumpers, that bias resistor, because we may need to reduce that, or we may not, I don't know. So the only thing I can hear humming now is the transformer. 85 watts. Go up a bit more. It's not going up a lot now. Is that bulb? It is, yeah. Right, let's take the 60 out, put 100 in. We've got 125 now. 125 watts on the of Bellobs. Much quieter. As I say, a little bit noisy, but that'll be this, no doubt. 192, that's good. Right, let's put 200 watt bulbs in. That'll zonk it up some more. So 200 watts of current limiting. Much quieter. I mean, you're just going to get a little bit of background hum. It's a single-ended amp. That's very quiet. These sockets, are they switchable? Need to look there. It looks like they are, yeah. Right, let's flick the current limiter off. We're drawing 160 milliamps. Flick off the current limiter. Shouldn't get much more because 200 watts of bulbs is a lot for this amp. 214 volts maximum. That's the maximum plate voltage on this amp. So what we need to do now is check the bias and see what we've got on that tube. So that's all running pretty good. Turn the volume down. Yep, I'll take that. It's been a good day's work. So I'm just going to use another meter. I'm just going to get a volts drop on here. 5.48. Divided by 150 ohms is 36 milliamps. That doesn't sound out of the window, does it? 36.5 milliamps actually. Now we need the plate to cathode voltage really, which means we're going to have to tip this thing up to get that, or are we? No, we're not, because we may be able to get it off that transformer. Let's just see what we've got here going on. First thing is we'll remove that. That's a bit dangerous. 214, what we got on that side? 205, so that'll be the plate. Right, 200 volts. .3 watts with that resistor in there, and I wouldn't really want to take that up anymore with that transformer. It's not very big, is it? So I'm going to have way too much voltage on that screen, on that tube, because that transformer is dropping a tremendous amount of voltage, I think. So if I put that on there, we've got 214, 206, so that's dropping 8 volts. That resistor's dropping 4, so that tells us that we're going to have more on that screen. Let's unplug, because that's all running nicely. That's good news. So I'm just looking at the screen on there now, which is pin 9. I'll have to use this other meter. $206, 215. Yeah, we're way over now. Tremolo is not particularly slow, is it? On it. So that's the slowest. And sorry, that's the amplitude. That's the slowest. And that's the quickest. Not a lot of variation in that, but it is what it is. Not something I ever use, you know, tremolo. Can't say I've ever bothered with it. Not that there's anything wrong with it, it's just one of those effects I've never used. So there we go. So I think what I'm going to do now, having got all that something like, the bias is way under, so we don't have to worry about that, and with that little plate voltage there's little point increasing it, and that transformer is tiny and there's just no point straining it by trying to bias this at 100%. What I'm going to do now, I'm going to put a screen resistor on this tube here, because makes the tube function better and the tube will last longer, although there's not a massive amount of current on this tube, is there? But even so, and it'll reduce that voltage a little. So I'm going to just cut out this trace here and just fit a screen resistor on there. 2.2k I think will do nicely for that. Right, there's our screen resistor in there. You can see, put onto that trace, and you can see I've raised it off the board in case it burns up, so it doesn't burn the board. We've cleaned the flux off with some alcohol, and here's a result. Right, just check the voltages again. Now we've got it up and running. 211 on the plate. And 210 on the screen. That'll do nicely. That's perfect, absolutely perfect, that. And of course we've got a screen resistor on there to protect the help protect the tube, make it last longer. 8.3 volts drop across there. Plenty good enough. That's spot on. So that all seems to be set up pretty well now. See what the cathode voltage is. Plate cathode. So 9, 1, 2, 3. Cathode. Plate. 204. 204. Very good. So we'll solder that 150 ohm resistor in, and I think there's one wire I've got to address on that transformer, looks a bit iffy, and I think that should do us. You can see now it's got more noisy as we've turned this over, and that again is all these wires and things going on there. But if we turn the volume down, you can hear virtually silent. Tone control works okay. Yeah, it's a shame couldn't get the bias up a bit more, but I don't want to push my luck with it. It's a very low plate voltage, so I think we'll leave that where it is. Right, you can see there we've got the milliamps, and what I've done there, that milliamp reading is across that HT fuse. So I've taken the HT fuse out and put the meter either side, and we're measuring the milliamps. So 36, 37 milliamps. So that's giving me an idea of what size fuse I want for this, because we don't want to be going mad. So I think 160 milliamp fuse will be plenty for that. Because we're not drawing a massive amount of current anyway, because the bias is only at 7 watts. And that is 36 milliamps is about what we got on the bias, so that so 160 milliamp fuse will be more than enough for this. In fact, I don't think I've got anything smaller than that, you know. I'll have to see what I've got. Right, so found another problem. Look at the volume control. Doesn't work very well on the first quarter of the turn. I've cleaned that quite a bit, and I'm afraid it's no-how. So that's going to have to be changed, I'm afraid. And a new pot in there. So it's pretty quiet when it's running now without the guitar plugged in, because these weren't grounded properly, the sockets. So I've cleaned those, got those grounded properly, and it's pretty quiet now. So we're getting there with it now. But there's just something else that I want to have a look at. So I've got the meter in shot there, and I'm measuring the plate cathode voltage, and it's 203 volts. Now this amp has got an EZ80 in it, and I've got here an EZ81. This one's a Valvo one. So what I'm going to do is tattle down, wait for that tube to cool down, and I'm going to just try this in it just to see if we get any more plate voltage. One way, of course, to get more plate voltage in this amp would be simply to remove the EZ80 and just put diodes in there, solid silicon diodes, that would increase the plate voltage considerably and take some strain off this transformer. Having said that, this transformer's not got particularly hot at any point, but then we've not really been pushing it. Right, we've got the EZ81 in. Let's just see what voltage we get. Up it goes. Oh yes, look at that. That's considerably more. It's coming down a bit now. 218. So not much more really, is there? But there is more definitely. 217 volts. We're 204. It's another 13 volts. Dropped a bit more, another 12 volts ish. So with that in hand, that's our plate volts, 216. We know the resistor's 150 ohms. Let's see what the voltage drop is. 5.6 we've got on there. So just check that resistor and just be 100% on it. I think that's 150 ohms is definitely near enough on that. Let's do a quick test then. We didn't take 5% off of the screens either when I did the bias the last time. Just remembered that for some reason. 37.33 milliamps. So that takes the bias up to 7.84. It was 7.3 before. So it's not really taking it up that much, has it? A little bit, but not a lot. But it was worth a bit of an experiment, just for a bit of fun, just to see. So if you're swapping your EZ80 for an EZ81, on average you get about 12 extra volts. Just one to log there, and certainly not worth going out and buying a tube. I mean, if your tube was blown, your EZ80 was blown, then it'd be worth buying the EZ81, but it's certainly not worth it just to swap it. When your day just gets better. So these pots are D-shaft. There's not a grub screw on them. So that's even more of a problem, because we've now got to find a D-shaft pot that's 1 meg. Bad show, old bean. Bad show. Right, we're going to give this Corvette a demo. So there's still, it's all back together, but there's still a couple of things. We've got a problem with that pot. I've checked all the normal places where I buy components, and no one's got one, so I'm going to have a serious search around for that. The problem is with these D-shaft pots is obviously the control knob will only fit on a D-shaft, and I don't want to end up with odd control knobs on this, so we've got to find the exact right pot. The other thing is the fuse, the HT fuse. I need to order some 120 milliamps, I think will be enough for this, because we've got slow start with that EZ80. we only got 36 milliamps going across that fuse anyway, so 120 should be plenty for that. 120 milliamps, so we've got to get that. We've got 250 in at the moment, and that's the lowest that I've got in stock. So anyway, enough waffling. This really could do with a decent speaker as well. That Elac speaker's not fantastic. With full toning now. Let's have a tinker with the trim now. So that's the quickest, the tremolo. The slowest, and that's as slow as it goes. Not a lot of difference, is there? Depth or amplitude. On that speaker, it just get a bit farty and distorted. going to the other input, got considerably more gain. And it's quite raunchy. See the pot again cutting out there. A lot more gain on there. So that's quite potent on that second input. So there we go. And that's flat out. Which we really don't want to do on that speaker. So there we go, that's a bit of a listen, and I can tell it, you know, this amp's biased far too low really. It's 7.3, well, take 5% off of the screen, that's going to be about 6.8 maybe, something like that. So it's biased way low, and I can tell when I'm playing that it is. You just when you've been playing for years through tube amps, you just know when the bias is wrong. But there's no, you know, raising the bias on this is pointless. And I did actually do a bit of a test. I actually paralleled a 380 ohm resistor which gave me 103 ohms, and it barely changed the bias at all. I think it was 7.3 we had, and it was 7.8. So, you know, you'd be down to something like 50 ohms, and yeah, it's the transformer just doesn't have, you know, enough voltage in there to push that tube at 12 watts. So I've just left that as it is. There's just no point. So all we need now with this amp, we need the D shaft pot, and we need a fuse, which is easy enough to order. The pot's going to be a bit more of a problem to get, but other than that, this amp's all done. And yeah, it really could do with a better speaker. That speaker is not great, but it is what it is. It's a budget amp. So that'll do it for this one. So I'd just like to thank everyone that supported the channel during 2024. You all know who you are. A lot of people have subscribed this year, and thank all those people that have done that. It's been great. It's been a great year, and hopefully 2025 will be a lot better still. So thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.